Hello guys, my name is Craig and welcome to Peri Solutions. In today's video, we're going to talk about how we calculate the angle between two straight lines, right, under vectors. But before we start, please make sure that if you're new to my channel, you hit the subscribe button and turn on the notification bell so that you don't miss out on any new videos. So from the previous video, we talked about how we calculate the angle between two vectors. Say for vector A, that is A1, A2, A3, and vector B, that is B1, B2, B3. Right, we say that for us to calculate the angle, we say cos theta is given by the scalar product of the vectors, which is A1, B1 plus A2, B2 plus A3, B3 over the magnitude of A times the magnitude of B. So we shall use this result to calculate the angle between two straight lines. But now the difference is that when we need to calculate the angle between two straight lines, we calculate the angle between their direction vectors. Right, so this is now for straight lines. Right, so now if we have to attempt these questions, right, the first part, number one, says find the acute angle between the two straight lines. So for part A, we've got r is equal to 5, 1 minus 1 plus t 215, right? And then we've got r is equal to 13 minus 60 plus mu minus 341, right? But we mentioned that for straight lines, we use the direction vectors. We calculate the angle between the two direction vectors. So we're saying cos theta, this is for 1a. So cos theta is equal to scalar product of the direction vectors. We're saying 2 times minus 3 plus 1 times 4 plus 5 times 1, right, over, plus 5 times 1 over the scalar, over the modulus magnitude of this direction vector, which is root of 2 squared, that's 4, plus 1 squared, that's 1, plus 5 squared, that's 25, times the modulus scalar, times the magnitude of this direction vector, which is minus 3 squared, that's a 9, plus 4 squared, that's 16, plus 1 squared, that's a 1. This. So here we end up with minus 6 plus 4 plus 5, right? So minus 6 plus 4, that's minus 2, and minus 2 plus 5, we get a 3. 3 over root of, this root of 30 times root of 26, right? Such that theta is equal to arc cos of 3 over root 30 times 26, right? Which will be equal to arc cos of 3 over root of 30 times 26. We get an answer of 83.8. And remember, this is to be an acute less than 90 degrees. So this is 83.8 degrees. This is the answer that we get. And then for the second one, for part B, 1B, this is now for 1B, we're doing the same thing. We're saying cos theta is equal to scalar product of the two direction vectors. We're saying this times this. That's what? 1 times 2 plus 2 times minus 1, then plus 3 times 4 over square root of first of all magnitude of this direction vector, 1, 2, 3. We're saying 1 squared, we get a 1, plus 2 squared, that's 4, plus 3 squared, that's 9, then times the square root of the modulus, the magnitude of this direction vector, 2 minus 1, 4, 2 squared, that's 4, plus 1 squared, 1, plus 4 squared, you get a 16. Right, such that theta would be arc cos of 2 minus 2 is 0, 3 times 4 is 12, 12 over the square root of, this is 14, so root of 14 times 21. Right, root of 14 times root of 21, which is root of 14 times 21. So we're saying arc cos of 12 over root of 14 times 21. We get an answer of 45.6. So 45.6 degrees is the answer that we get for theta, 45.6 degrees, right? And this is for the second part. And now for the third part, one part C. First of all, we're just considering these direction vectors. So we're saying cos theta is equal to scalar product of the direction vectors. We're saying 1 times 2, we get a 2, minus 1 times minus 3, that's a plus 3, right? And then 1 times 1, that's simply 1, over magnitude of this direction vector, 1 squared we get a 1, plus minus 1 squared, that's a 1, then plus 1 squared, that's a 1 as well, which is just root of 3, right, times root of magnitude of this direction vector, 2 squared we get a 4, plus minus 3 squared, that's a 9, and plus 1 squared, that's a 1. And this will be equal to, here we get 6 over, this is 14, 14 times 3 is 42, so root of 42. Right, such that theta is equal to arc cos of 6 over root 42. And this would be equal to arc cos of 6 over root 42. That will be equal to 22.2 degrees. Right. So 22.2 degrees is the answer that we get. 22.2 degrees is the answer that we get for part C. Right. Now let's move on to look at number 2, which is the last part. Shall we erase this part here? Right. So number 2 says, show that the following 2 lines are perpendicular. So the application, the result is just the same. For perpendicular lines, right, we said for 2 perpendicular vectors, their scalar product is equal to 0. So same applies here. For 2 perpendicular lines, the scalar product of their direction vectors should give us 0. So simply saying minus 2 minus 4, 5, dot, minus 11, 3 minus 2, should give us 0, right? So saying minus 2 times minus 11, that's 22, and then minus 4 times 3, that's minus 12, then 5 times minus 2, that's minus 10. This should give us 0. Then there's 22 minus 22 to give us 0, and 0 is equal to 0. So this proves that these 2 lines are perpendicular. So this was how we calculate, this is actually how we calculate the angle between 2 lines, right? We just simply use this formula, cos theta is equal to the scalar product of 2, right, of the scalar product of the 2 direction vectors, right, over the magnitude of those direction vectors. This is how we calculate the angle between 2 lines. Right, so please feel free to leave a comment, drop a like, and don't forget to subscribe. Thank you.